Okay, in this video we're going to go through the solutions to the homework that you received on October 17th in 2013. I want to make sure that you have your TI-84 or TI-83 with you because we need to do this together. You need to not just watch me. And so if there are points in the video when I go too quickly, I need you to pause the video and see if you can go ahead and do the problems as we work through them together. Okay, so number one was to find all the zeros of the given function, 10x to the fourth minus 13x cubed minus 73x squared plus 65x plus 115. So the very first thing that you would do on a test or a quiz to do this correctly is you would first form your ratios, find all your p-values, which are the divisors of the final number, and all of your q-values, which are the divisors of the first number. And actually, I noticed right here, I'm missing one. I should also have a plus or minus 10 also. So this is not a complete list, but for right now, it's good enough. Then what you do after that is you go to your calculator. And that's what I'm going to do now. I'm going to open up my calculator program, and I'm going to go ahead and I'm going to enter my function. So now I have my function entered. Let's check our window, and let's just start with the good old standard, negative 10 to 10. Negative 10 to 10. Just to see what we get. Let's hit graph. So what I've done is I've gone to Window, set my X values from negative 10, let me change this here, to 10. And then my Y values from negative 10 to 10. And this is a basic shape of what the graph looks like. Now, I know that I can limit my window because I have a bunch of dead space here and a bunch of dead space here. So now, let's go back and let's limit our values here from negative 3 to 3. Hit graph again. And now we have a pretty good shot at doing this right here. I notice that this seems to go through negative 1. So I want to figure out if that's true. Well, there's a way to test it. You can use your calculator by hitting variables, y1, and plugging in negative 1. Ooh, make sure to use the negative key, not the minus key. There we go. Enter. Yes, it's confirmed. So that's when we start to do this synthetic division right here. Drop the 10, go through the synthetic division, and you get a remainder of 0. So now what you have is 10x cubed minus 23x squared minus 50x plus 115. Now, we're going to go back to the calculator, and we've confirmed that negative 1 is indeed a 0. Well, let's try this one right here. So what I'm going to do is I'm going to take my cursor here, and I'm going to go over to the left to right about here, and I'm going to zoom in. And I may need to do this a couple times. There's the first zoom in. And let's just zoom in one more time. Okay, I'm going to hit trace. And I notice that my point here is below. And here's a point that's above. So now I'm going to use the calc feature. Second calc 0. I'm going to use this as a left bound, so I'm going to hit enter. I'm going to go down below, use this as a right bound, hit enter, and now it's going to guess for me. Now, look at the answer I get, negative 2.236068. This is a pretty good approximation, but chances are pretty good because of the decimals that we're getting here, it's an irrational number. All of the ones I'm going to give you on your tests and quizzes will be nice. Something like 2.3, 1.8, something with pretty much one decimal. So this is most likely an irrational number. Now what that means is that even though this is a good approximation, we need to find something that's nice. So let's go back to our window and let's zoom back out to negative 10 to 10. Negative 10 to 10. Okay, so now we're going to zoom in on this region here. So I'm going to scroll over without hitting trace. Zoom in. Okay, let's use the zoom feature again. And this is looking pretty good. I'll hit the trace key and see if we can find a point here on the graph. There we go. Okay, let's try this one right here. So I go to second calc, 0, use that as a left bound. Go to the right one, make sure it's below the x-axis, use that as a right bound. Guess. Ah, beautiful, but check this out. This is another approximation. Actually, this turns out to be the positive of what we just had. And look at all those digits. So again, this is most likely an irrational number. So now let's try this guy right here. So we use the key to come over, hit trace, come over to this point right here. Second calc, back to here, enter. Let's use this one to below as a left bound, and this one above as a right bound. Beautiful, 2.3, so he's the winner. So now we go back, synthetically divide 2.3, which by the way, if I include plus or minus 10, I get 23 over 10, which is 2.3, so it should be in the list. My list here isn't complete. Synthetically divide 2.3 and I get 10x squared minus 50. So I get this. Factor out a 10 and I get x squared minus 5. Set that equal to 0 and we get plus or minus 5, and those are the remaining zeros. So this part factors into 10 times x plus 5, x minus 5, and the other two zeros here become these factors. So the function factors as 10 times x plus 1 times x minus 2.3 times x plus square root of 5 times x minus square root of 5. These are the zeros of the function, and that's how you use your calculator successfully to find all of the zeros. Number 2, graph the rational function. What you need to do is you need to be able to graph all of your x-intercepts, all of your y-intercepts, all of your vertical asymptotes, and all of your horizontal asymptotes. So let's start with the x-intercept. To find the x-intercept, all you need to do is set the function equal to 0. Well, if you do that, it turns out that it's only the numerator that matters. So when does the numerator equal the number 0? When t is equal to negative 2.5. By setting this equal to 0, you can solve it, negative 2.5. So that means it crosses right here at the x-axis. I saw a lot of students just graph any old thing and say that that was good enough. And it's not good enough. You have to make sure you label your points correctly. So it goes through the x-axis here at negative 2.5. To find the y-intercept, all you do is you put 0 in for the variable t. So this becomes 5 over negative 4, which is negative 1.25, which is this point right here. Now, the vertical asymptote is at t equals the number 4, because that's where I would get 0 in the denominator. So now you graph a vertical dashed line going through 4. The horizontal asymptote is when we let t go to infinity, when we let t get really large, and that's when we drop the insignificant terms. In the numerator, the insignificant term is 5. And in the denominator, the insignificant term is -4. So we drop those two, and we're left with 2t over t, which is 2. So the horizontal asymptote is a horizontal line through 2. So I want you to graph both the vertical and the horizontal. Now we have enough to go by. So what you're going to do next is you're just going to plug in some random points like 1, 3, 5, -2, -3, and get some other points. And when you sketch those points together, your function will look like this. Notice it hits the x-axis right here at where we predicted, and it hits the y-axis here at where we predicted. This portion is completely above, and so we don't hit any axes here. That's how you graph the rational function. Number 3, solve the following equation. Well, what you need to realize is that 125 is 5 to the third power. Now you distribute the 3 into the x plus 1. So 5 to the 2 minus x is the same thing as 5 to the 3x plus 1. And if the bases match, this is the one-to-one property right here. The one-to-one property says that we can drop the bases. And so when we do that, we get 2 minus x is 3x plus 3. -1 equals 4x, so x has to equal -1/4. And that's the solution to this equation. Number 4, solve the equation log x plus 1 equals log 4/9 x squared. Well, since the logarithms match in the base on both sides, we can drop the logarithms. So this gives us x plus 1 equals 4/9 x squared. Now to make our life easy, what we do is we multiply everything through by the number 9. So 9x plus 9 equals 4x squared. Subtract these two to the other side, and we have 0 equals 4x squared minus 9x minus 9. And now we can use the quadratic formula. Using the quadratic formula, we get 9 plus or minus square root of 81 minus 4 times 4 times -9 all over 8. Well, 81 plus 144 is what we get under the root, and that's 225. The square root of 225 happens to be 15, so we have two different values. 9 plus 15 over 8, which turns out to be 3, and 9 minus 15 over 8, which turns out to be -3/4. It turns out that if you put both of these values into the logarithms, you never get a negative argument. They're always positive for the argument. And so you get something that actually works. And so both of these are valid solutions to the equation. Number 5, place this into logarithmic form. 5 is the base. F of x is the power, or the logarithm. X plus 8 is the argument. So this becomes log base 5 of x plus 8 equals f of x. And that's logarithmic form. Number 6, graph the exponential function. Now remember, in chapter 2, we spent all that time doing transformations. So you have to realize that if f of x is 3 to the x power, then what we're looking at here is simply f of x plus 2 minus 2. So this is a translation of 2 to the left and 2 down. Now when it comes to exponential functions, you have to know that the key point for an exponential function is originally 0, 1. And what you do is you perform the transformations on that key point. So 2 to the left and 2 down means that 0, 1 goes to -2, -1. The horizontal asymptote of the key function, the original function, is y equals 0. But then you do the transformation of 2 down, and you get y equals -2. So again, graph your horizontal asymptote here. Your y-intercept will be at 7 when you plug 0 into this function. And then you can graph the exponential like follows. And that's how you graph this particular exponential function. I want you to use what you learned about transformations. You can use all of that transformation stuff that we learned on all of the functions that we want to graph. These ones were simply evaluate. -2, 0, 21, because natural log of e to the 7th is 7, and 7 times 3 is 21. 5, undefined. The argument of a logarithm can never be 0. There is no real number when you have an argument of 0. This is called undefined. 1, and this one should not be 1. This one should actually be 7, so that needs a correction. That should actually be 7. Number 8. Given the function, if 3 plus I is a 0, then by the complex conjugates theorem on page 170, so is 3 minus I. What this means is that x minus 3 plus I and x minus 3 minus I are factors of the function. So what we're going to do is multiply them. So we set them up like this. After we multiply, I want you to multiply this out by hand by yourself and make sure that you get the same thing here. This is the correct answer. You're going to get x squared minus 6x plus 10. And that means that this is a factor of the original function. So we can divide it. So we perform long division. We divide this into the function. X squared goes here. X to the 4th cancels away. We reduce that. Then we get x to go here. Reduces again. Minus 6. We get a remainder of 0. This is what we get as a quotient. So this is factorable. This becomes x plus 3 times x minus 2, which means the zeros are -3 and 2. So what I've done is I've circled all the zeros. -3, 2, 3 plus and minus I. Those are all the zeros of the function. 9a, we're going to simplify. So we multiply these two together and distribute the 3. So we get 10 minus 4i plus 15i minus 6i squared plus 6 minus 3i. This gives us 16 plus 11i plus 6 minus 3i, and that gives us 22 plus 8i. Simplify. Notice the denominators are exactly the same. That means you have common denominators. So you can just add the numerators now. So now you get 8 minus I over 2 plus I. Now we can't have a complex number in the denominator. So we multiply top and bottom by the conjugate of 2 plus I, which is 2 minus I. FOIL out the top and the bottom. You're going to get 16 minus 8i minus 2i plus I squared over 4 minus 2i plus 2i minus I squared. The denominator becomes 5. And the numerator becomes 15 minus 10i. Both numbers are divisible by 5. So we finally get 3 minus 2i as an answer. 10. Find the inverse and graph both functions on the same axis. So from the lesson that we did in chapter 1, to find the inverse, you have to switch x and y. So I do that. X equals 5 times the cubed root of y minus 2 minus 8. And now I solve for y. So I add 8 to the other side and then divide by 5. I get x plus 8 over 5 equals the cubed root of y minus 2. I now cube both sides to get rid of the cubed root. X plus 8 over 5 cubed equals y minus 2. And finally I add 2 to the other side. So the final inverse is x plus 8 over 5 cubed plus 2. After that we can use our graphing calculator. Every time I ask you to find and graph an inverse, I want to see this line y equals x. So here's the original graph right here, and here's the inverse graph right here. And you can use your calculator to do that and work that out. All right, those are the solutions to the homework that you did on 10/17 of this year. So I hope that is helpful to you. God bless you wherever you are today.
Praise Father, Son,